Hello, welcome to today's video. Today we're going to talk about trigonometry again, and we're going to find the unknown angles. So this involves using the inverse trig ratios, okay? So sine minus 1, cos minus 1, and tan minus 1. Before we start, we're going to go through defining trigonometric functions, okay? So what is a function? And you might have heard of a function before in maths, but maybe not. You might have heard it in programming or computing or something. But basically a function is something that does something. So it has an input, so a number coming in, and it does something maybe magical to that number, and that is called a process, or what the function, or an operation, or what the function does. And then you've got an output, so it spits out a number. So that's exactly what the sine, cos, and tan functions do. So, for example, squaring something might be a process. You might have the input, which could be the number 3, and the process squaring, and the output would be 9. So 3 squared would be 9. So the process would be squaring there. This can also apply to the trig functions we're very familiar with. So sine, cos, and tan. With each of those, with all of those, you have an input of an angle. So sine of theta, cos of theta, or tan of theta. And they all spit out those common ratios that we're familiar with. So SOHCAHTOA TOA. So sine is O over H. It'll spit out an O over H ratio. Cos will spit out an adjacent over hypotenuse ratio. And tan will spit out a opposite over adjacent ratio. Okay, so we can think of these functions as inputting an angle and outputting a right angle triangle side ratio. Okay, now what we're going to talk about today is the opposite functions to these, or the inverse functions to these. And so these are sine minus 1, cos minus 1, and tan minus 1 functions. All they really do is now they insert the ratio, so O over H, A over H, and O over A, and they spit out the angle there. So they really just work in the opposite direction. So inputting a ratio and outputting a angle. Okay, now these here are known as the inverse operations. Okay, so it's like when we square something, the opposite is to square root it. In this case, if we sine something, the opposite operation is to inverse sine something, like sine minus 1. Okay, all right. Now let's go through a worked example, or an example of a sine minus 1 using a sine minus 1 function. And this is how we can find unknown angles. Now sine minus 1 is also called arcsin. That's another name for it. Cos is the same as cos minus 1, and tan minus 1 is similarly there, arctan. Okay, here we've got a right angle triangle. The opposite side there is 2, and the hypotenuse side is 5, and we've got an unknown angle theta. That's what we want to find out. The opposite, we know that 2 is the opposite, and the hypotenuse is 5. Okay, if we know our trigonometry from before, we know it's a sine function, so it's sine of theta equals O over H. Okay, and we would replace sine. So keep sine theta there, and replace O and H by 2 and 5. Okay. Now, what we're going to do is the opposite operation on both sides. So we do sine minus 1 on both sides. Sine minus 1 of sine theta equals sine. So on the left-hand side, we did sine minus 1, and then we do sine minus 1 again, and we get sine minus 1 of 2/5. Okay, so we've done the opposite operation on both sides. So on the left-hand side, we're doing sine minus 1, then sine. Effectively, we're just going from angle to ratio, and then from ratio back down to angle. Okay, so on the left-hand side of that equation, so sine minus 1 of sine theta, that will actually just lead to, and we'll see it here, sine minus 1 of sine theta actually just leads to just theta. It gets back to our angle. Okay, and so right hand side we just leave as sine minus 1 of 2/5. Okay, So simple little equation here, theta equals sine minus 1 2/5. Okay, now we're going to use our calculator. All right, and just using Google here, we set our calculator to degrees, so you can see that toggling there. Degrees, deg is highlighted there. The next bit is we click the inv button, which is inverse, and I just quickly click the sine button. It comes up with sine there. Okay, so that comes up with arcsin, and we put 2/5 there. And then we press enter, and magic, we get the angle. So 23.6 degrees if we round it to 1 decimal place. Okay, so 23.6 is our answer. In degrees, and that looks about right based on that picture there. Okay, thank you for watching this video again, and make sure if you've got any questions, I only did one example here. You can apply this certainly to the cos ratio if you know what the adjacent and hypotenuse sides, or the tan if you know what the O and A are. Okay, thank you for subscribing, and definitely add some comments below, and I'll see you later. Bye.